Okay, so now let us talk about a very important form of limits, or the another indeterminate form that is very important as per se your syllabus is 1 raised to power infinity form. Very important form, right? And the basic formula, if I have to talk about the basic formula for this that you people should actually remember is limit x approaching 0. In the base you have 1 plus x, so you can see as x approaches 0 this tends towards 1, and in the power you will have the reciprocal of what is written here. So this formula is nothing but e, and if I have to generalize this formula, I could say x approaches a 1 plus fx, where I could say 1 by fx here. This would be e when as x approaches a your fx approaches 0. So still if you see, this becomes a 1 raised to power infinity form. So this is much more important that you should realize what form it is. So it is 1 raised to power infinity form in this particular case. Okay, got it? And this is the other formula that you people can remember, that if it was 1 plus k times fx and only 1 upon f is there, so the answer will be e raised to power k. Though you can simply solve it without even remembering this kind of formula, right? So if we were to apply this in this case, so what it will become, see, so 1 plus k fx, I need the reciprocal of the entire function, that is k fx. So here I can multiply and divide by k. Okay, that is what I can do, and I know that limit fx is tending towards 0. Okay, so this is given to us. So if I see this particular whole stuff here, this particular stuff, so this reduces to e, right? This k also here, k is also included here. Okay, and you are getting only what is remaining, e raised to power k. That is why we say e raised to power k. So don't worry about this front, you just remember these two formulas that we have done here and here. We'll try to solve them in the question so that it becomes comfortable for you. Okay, let me take the first problem. So it says you have to solve this particular limit. First of all, again, figure out what is the type. So if you put x equal to 0, the numerator becomes 1, denominator becomes 1, so this becomes 1, and 1 by 0 is infinity. So this is of the form 1 raised to power infinity. For 1 raised to power infinity form, you need something of the sort 1 plus x raised to power 1 by x, or you need something of the sort 1 plus fx raised to power 1 by fx form, right? This is the form that you people require for this particular formula to be applicable over here. Now let us start working on this particular concept. So how do we form 1 plus fx? Here you can see that your fx component is 1 plus 3x square upon 1 plus 5x square. What I did in this particular question is I just added and subtracted 1. And that could be done anywhere in any kind of question, irrespective of limit. We can anywhere do add or subtract a same number, no change, the limit is still equal, right? And if we see and check now, let's see, so this becomes what, 1, and this, if you take the LCM, then what it would become, tell me? Yes, so it will reduce to what? It will become minus 2x square 1 upon 5x square whole raised to power 1 by x square. Okay, so now if this is your new fx, if I talk about this is your new fx, what is the value of fx as x tends towards 0? Yes, so this new fx is tending towards 0, new fx is going towards 0, so that means this becomes 1 raised to power infinity form. But what you people required for this to be valid was, let me just rewrite it again for you. So this is the formula for f, right? This is your new f, you can say. Okay, so now what you people required was that the reciprocal of this particular function should be here. Okay, so you wanted something of this sort, 1 plus 5x square upon minus 2x square here, right? So you can do this, not a problem. So what I did, this step I multiplied and divided by the same quantity in the power, and there is also still 1 by x square left. Can I do this? See, and if I talk about this particular whole stuff, see here up till this component, So what it will reduce to? This particular whole stuff. This particular whole stuff here will get reduced to your e, right? Why? Because it is 1 plus 0 raised to power 1 by 0 form, right? And you will be just left with simply minus 2x square divided by 1 plus 5x square into 1 by x square. And if you see this, you are just x square gets also cancelled. The limit that you have to solve in this particular case would be e raised to power minus 2 by 1 plus 5x square. And now you can easily substitute the value of x here, no problem. So the answer to this particular limit will become e raised to power minus 2. This is the answer we were looking for. This is the particular answer, right? I hope the question is clear. So do not worry about the function. So here the function, the new function was a bit complicated. So if I have to write the new function here, new function was minus 2x square upon 1 plus 5x square. So don't worry about this, that this is complicated. Doesn't matter if it is complicated. For me, it is not complicated. It is as x approaches 0, the fx approaches 0. This is what I understand out of this. Okay, let's apply this particular concept in the other problem. Now let us solve the other problem. This again says that you want to find the limit of this. Again, first of all, figure out what form it is. That is the most important thing that you can do in limits. Figure out the form. So if you put x equal to 0, everything in the numerator will become 1, 1 raised to power 0, 2 raised to power 0, and they are added till n times. So it will become something of n by n raised to power 1 by 0 type. And if you can see, this is nothing but 1 raised to power infinity form. So this question entails to 1 raised to power infinity form. And immediately as you have, if you get to this particular, concept, your mind should start working on something of this sort. You should now start thinking on how to form this particular thing. There is already 1 by x. I need to express the base into 1 plus x form. For doing this, there is no problem. I guess this is the most generic way which I can teach, that add and subtract 1. You just add and subtract 1 in these type of questions whenever you get them, right? So if you add and subtract 1 over here, right? So this is the particular stuff. Okay. So now if I take the LCM in the base, so what it will reduce to 1 plus something of this sort could be written, and this then will become minus n, right? Okay, by 1 by x. Now the target is how do we simplify this particular concept. So now first of all tell me whether this reduces to 0 or not. This. So this is your fx here. So if I say the formula is 1 plus fx raised to power 1 upon fx reduces to e, right? If I say this is x approaches 0, so as x approaches 0, fx also approaches 0, so then this limit will become e. Is this happening over here? See to it. If you put x equal to 0, this entire stuff is, yes, entire stuff becomes 0. Why? Because this is 1 plus 1 plus 1 added n times. Minus n will give you 0. So what I needed here was limit x approaching 0. Let me assume this as fx. So you wanted 1 plus fx, but rather than 1 by x, you wanted 1 by fx to be there. So what I did, in the power I multiplied and divided by fx. Okay, so this, but still we have 1 upon x here. Okay, got it. So if you check properly, so this entire stuff over here, this particular concept, right, will reduce to what? 1 raised to power infinity form. This will reduce to, yes, this will be nothing but e, right? And you will be left with e raised to power fx by x. Since base is a constant, so need not worry. So limit will actually get involved in the power, right? This is how you will see this question. So now let's see how to solve this particular step over here. So now we are just focusing on, let's say, in fact, we will try and solve only this. So what this limit will become? Limit x approaching 0, fx is this particular value. Okay, so that is 2 raised to power x, 3 raised to power x, up till n raised to power x minus n. Okay, Now you have nx in the denominator. Okay. So how this can be resolved is very simple again. We know a formula, that is a raised to power x minus 1 upon x is ln a when x tends towards 0. Remember, we did for the exponential functions. This is what we're going to use in this particular case. How we are going to use it, let's see. So this becomes nothing but limit x approaching 0, 1 raised to power x minus 1. Let's make this as this brackets. So I have splitted this n in n times 1. I made n times 1 out of this, n times 1. Okay. So and I subtract each of them in this particular bracket. So the last will be n raised to power x minus 1. And then I did what? I individually put x in the denominator. Okay, so now we are just left with 1 by n. So we can say that you have to still, this is your bracket. Okay, and we need to multiply by 1 by n also. Now, can you see that these are nothing but your n exponential functions written over the board, right? So this is nothing but an exponential function where the value of a will be taken as 1. Let me just change the pen to highlight it for you. A is 1, here a is 2, here a is 3, and the last one a will become n. So this is nothing but 1 by n into what this will become ln1, ln2, ln3, goes on till, yes, ln n, right? And if we start applying the property of ln's, that is log, what it will become? What is log a plus log b? Yes, so the answer, I am just writing the answer is 1 by n, and you can say ln 1 into 2 into 3 up till n, right? What is this particular stuff? Yes, this becomes ln n factorial by n, right? So this is what you will end up with. And remember that we just have solved this particular power here. We just calculated the power, right? The answer was e raised to power, right? So we wanted e raised to power here. The answer to this particular problem then would be, yes, so the answer, the final answer here would be e raised to power ln n factorial by n. Okay, and if you want to reduce this, then this will become e raised to power ln n factorial raised to power 1 by n, which could be further resolved to nothing but the answer to this problem then would be e raised to power ln n will be n factorial raised to power 1 by n. So this is the particular answer we were highlighting in this particular problem. Okay, just go through the problem once again. Very beautiful problem to understand this particular concept. Okay, so the next problem is something e raised to power. So I'll just write the limit for you again so that it becomes much more evident what we want to solve. So this is something what we are trying to solve. Now this time around, what is the form here? Which form it is? This is not 1 raised to power infinity form, that's for sure, because the base is given to be e. So we do not know how to solve this. So what we understand here is that the variable is in the power. Variable is in power form, right? So how to reduce power to the base? Yes, this is how you should think. So we need to take log here for reducing power to base. So let's say the answer to this particular limit will come out to be a. That is my assumption, that I have taken that this limit is equal to a, and what I will do now, I'll take log on both sides. So I'll take log a. So this limit will reduce to limit, the variable of limit still remain the same, that's not a problem. This will become 1 by x log e, and let's assume that I have taken log with base e, right? Log with base e is what I have taken, with base e is what I have taken. So this will reduce to 1. Okay, so this becomes ln a is equal to limit x approaching 0 1 by x log x. So now this is what you need to find now. This is the new limit. Can you tell me how you will solve this particular limit now? It seems to be that this particular x is 0, this particular, so what is something of log when log is approaching 0? Yes, so this is something which I expect that you people should remember. This is minus infinity. Why? Because the graph of log is something like this. right? So if you start approaching towards the zero component, your graph is moving towards minus infinity, you can see here. So this is something in the denominator, it is like approaching 0 into approaching minus infinity, which we again do not know how to solve. So this is something into 0 into infinity form. If you want to remember how to solve this, you should remember that you should convert this to infinity by infinity form somehow or the other. That is the target. And how do we do this? Very simple. Let's see. What I can say here is it is limit x approaching 0. I would say I write this as this. Since both of them are same, that's not a problem. I just wrote 1 by x in the numerator. So if I see this, this is my numerator and this is my denominator, right? So what is the numerator now? So numerator is 1 by x. So as x approaches 0, that means numerator tends towards not 0 but infinity. And the denominator that I am having is log x. And again, as x approaches 0, denominator tends to be infinity, or I can say minus infinity. This reduces to your infinity by infinity form. Don't worry about the negative sign, right? So you can say minus infinity by infinity form. Not a problem. If this is there, that means you can apply. Yes, now the LH rule is applicable. This is what I meant by here. So if you start apply LH rule here, what the answer would become then? It will become limit x approaching 0. What is the derivative of 1 by x? Minus 1 by x square. And what will be the derivative of log x? That will be 1 by x. And if you solve this completely, your answer would be minus limit x approaching 0, 1 by x, right? And what would be the answer to this particular? Let me write it over here then. Then the answer to this particular form would be nothing but minus infinity, because we know that 1 by x is nothing but infinity. Got it? Okay. So here the entire question then reduces to, this is not your answer first, right? You have taken this to be ln a. Ln a comes out to be minus infinity. Remember? See here again, you were solving ln a. So ln a has to come back here. So ln a is equal to minus infinity. Then what will be your answer? A is equal to e raised to power minus infinity, or you can say 1 by e raised to power infinity. Then the net answer would become fraction raised to power infinity is, yes, so a is nothing but 0. This is the answer you were looking for. Rewatch the video for this particular question. Very important problem. There is something where variable is in the power, then you will have to take log to solve the particular limits problem. I hope this question is clear now.